Now, in my previous clip, I was explaining how sigma notation works. When we are working with this kind of problem, we'll want to be adding up lots of things, but we won't want to write out exactly what each term in the summation looks like. And I use the word summand for the things that I'm adding up. So instead, I can specify a formula that all of the numbers are supposed to follow. So here, I've got the height of my number k rectangle. I've got the width of my number k rectangle. And I need to add these all up, starting at k equals 1, stopping at k equals 10. If you happen to be in any kind of computer science, then you might think of these as maybe like a loop where for k from 1 to 10, I'm going to add these kinds of numbers up and then produce a result. If you're not a computer science person, that's fine too. I'm not a computer science person. That is a helpful metaphor for people that are. Now, I wanted to find the area of these rectangles here. And fortunately enough, most graphing calculators are able to calculate these kinds of sums for us. Calculators are very fast at adding things together and multiplying things together. Those are some of the things that computers are the best at doing. Now in Desmos, I'll write the word sum, S-U-M, and Desmos gives me a capital sigma. I need to tell it where to start, and it's using the letter N instead of the letter K. That's okay. So I'm going to copy in my formula here. So I've put in my formula. I'm adding up heights of rectangles times widths of rectangles, which means I'm adding up areas of rectangles, and Desmos tells me that I get 1.997 and change. But I'm supposed to get better answers by using more rectangles. So let me think about this formula that I've got and figure out how I can make this more general. So what did I have in my sigma notation? I've got a sum, right? That's just what the letter sigma tells me I'm doing. I start the sum. Maybe I'll use n to match what Desmos is doing. So I'll match my formula over here on the left. N has to start at 1 for the number 1 rectangle. How many rectangles am I going to have? Here I had 10. Maybe I could have some other number. Okay, well, I want 100. No, I want 1,000,000. No, I want 100,000 million and 6. I can be very fickle with this kind of stuff if I want to be. So instead, I will use a different variable. So my capital N here is just some positive integer. I have to stop somewhere. This is the number of rectangles that I'm choosing to use. Okay, so my function, where am I going to find these heights? Well, how wide are the rectangles? My total interval is 1 unit wide, and if I'm dividing that up into n pieces, each piece must be 1 divided by n units wide. So my first rectangle here, I am measuring the height at 2 plus 1 divided by n. For rectangle number 2, it'll be 2 plus 2 divided by n because I moved over twice. For rectangle number 3, I move over 3 times. For rectangle number 4, I move over 4 times. So my formula looks like this. So I can still think of this as height of rectangle number n times width. And each of my rectangles has the same width.